11.1 Angle Measures and Polygons. We talked about the sum of the interior angles in a triangle. The sum of the interior angles in a triangle is 180 degrees. And we also talked about the sum of the interior angles in a quadrilateral by dividing it into two triangles. This triangle, this angle, we add up all these angles, these parts, we have two triangles, so 180 and 180 makes a total for 360 degrees. And we can do this to figure out the angle measures for any polygon by splitting it into 1, 2, 3 triangles. 3 times 180 equals 540 degrees. Or in this case, the diagonals from one vertex is 4. 1, 2, 3, 4. So 4 times 180 is 720 degrees. If we back this up, this would be like 2 times 180 and 1 times 180. So if we wanted to figure out the sum of the interior angles for any polygon, notice the connection between the number of sides. This has 3 sides, 4 sides, and the number we're multiplying 180 by. Number of sides minus 2 will tell us this number. 5 sides, if I took 2 away from it, 3 times 180. Taking 2 away tells the number of triangles. So the polygon interior angle theorem, the sum of the interior angles of a convex pentagon is the number of triangles, n minus 2, times 180. So you can use that formula to figure out for any polygon with n sides. The corollary to this theorem, a theorem that follows easily, measure of an angle of a regular polygon. So regular polygons, all the angles are the same. So we're going to use that same formula to figure out the sum of all the angles. And now divide it by the number of angles. So the sum of all the angles divided by the number of angles, since all the angles are the same, will tell us the measure of a angle. Now, notice an exterior angle is going to be this angle here. That's an exterior angle, and if we want to know something about the sum of the exterior angles, one at each point, as you made this smaller and smaller, it looks more and more like a circle. Total degrees around, you add up all these angles, we're at 360 degrees. Okay, and that's the next theorem. The sum of the measures of the exterior angles of a convex polygon, one at each vertex, is always 360 degrees. Okay, don't think it's a trick question. The measure of each exterior angle of a regular pentagon. So this one has 5 sides. If all of them are 360, one angle here would be 360 divided by 1, 2, 3, 4, 5, or the number of sides. 360 divided by n. So we can find the value of x in the diagram by first identifying the type of figure. This has 5 sides. So 5 minus 2, I'm using the formula to figure out the total sum of the angles. The total sum of the interior angles is going to be 540, right? Because n is 5 sides. And from here, to figure out what x is, I could write an equation. Basically, if I add up all these things, add these all together, it's going to equal 540. A quick, oops, shoot, I think this is about 436. I might be wrong, but if this is 540, then x equals 104 degrees. Okay, the measure of each interior angle of a regular polygon is 165 degrees. How many sides does the polygon have? The book method uses corollary 11.1, and Dakota Dorn, he found a method that he liked better, so I like to show both, and I give the Dakota Dorn method credit. He was the first one to show it to me, but to answer this question, if each interior angle of a regular polygon is 165 degrees, how many sides does it have? So it's a regular polygon, all the angles are the same, number of angles is the same as the number of sides, and the book uses this formula to figure out the interior angle of 165. And they solve this thing, 1 over n times n minus 2. Notice multiplying by 1 over n is the same thing as this divided by n. So if I was going to solve this, I would first multiply both sides by n, get n minus 2 times 180 equals 165n. And from here, distribute 180n minus 360 equals 165n. Subtract 165n from both sides. You get 15n, and I'm going to add 360 to this side. Now when I divide by 15, n equals, on there, 20, be 300, 15 goes into 60 4 times. So it would have 24 sides. Now, the Dakota Dorn method, he figured out what the exterior angle was. So if the interior angle is 165, he said, well, that means my exterior angle is 15 degrees. And then he just used the fact that 360 divided by n is going to equal that exterior angle of 15. So at this point, he cross-multiplied and divided, took 360 times 1 divided by 15, and he said n equals 24. So this is kind of a slick method. It takes a little bit more algebra, geometry, intuition, but a lot less algebra. So I do like this for how fast it is. Okay, but it all relied on finding the exterior angle for the problem. Okay, next example, example 3. Find the value of the variable in each diagram. What do we know about all the exterior angles? One exterior angle at each vertex. They all add up to 360, so y plus 2y plus y plus 2y. We add those all together, we get 6y equals 360. So y goes in there 60 times. So find the value of the variable in each diagram. Another diagram down here. How do I find x? Notice this is a regular hexagon. It has 6 sides. It's a regular hexagon. I know all the exterior angles. It's add up to 360. Since this is a regular hexagon, all these angles are going to be the same, so I can take 360, divide it by the number of sides, and x is going to equal 60 degrees. The sign on a building has a long, narrow hexagon shape. Kind of a long, narrow hexagon shape to it. So notice I'm drawing a picture to help me out. 4 of the interior angles measure 140 degrees each. The remaining 2 interior angles at each end of the sine are congruent. X. Let's call them X because we don't know what they are. What is the measure of each angle? Well, what's the total sum? So we can use that formula n minus 2 times 180 for the total sum. In this case, since it has 6 sides, we put 6 in for n, and we get 720. So now I can say 720 equals all these added up. So x plus x is 2x. 140 times 4, so there's 4 of them. 560. If I subtract 560 from both sides, I get 160 equals 2x. Divide by 2, x equals 80 degrees. If you were designing a sign for a new building, would it be possible to make a sign that is a regular polygon with each angle having a measure of 160 degrees, 115 degrees? So each angle. So basically, can I make a polygon with a 160 degree angle at each vertex? Or will one of them have to be different? So using that Dakota-Dorn method, I'm going to figure out if the interior angle is 160, this exterior angle is going to have to be 20. So if I take 360 and divide it by n, can I get something to equal 20? Is that going to be a whole number of sides? So if I cross multiply and divide by 20, figure out what n is. I know 20 goes into 105 times, so this is going to be 15, 18. So yes, you could have a regular 18-gon. How about for 115? You're going to do the same kind of thing. 360 divided by n. Going to tell the measure of an exterior angle, but this is an interior angle, so this has to be the exterior angle. If this is 115, these add up to 180, so 65. Yep, that looks good. So if the exterior angle is 65, does this work? And cross multiply and divide is 360 divided by 65 come out to be a whole number. 60 goes into 360, but 65 does not come out to a whole number. Going to be 5, that's 325. So you got a remainder of 325, 35. So it's not a whole number. You can't have a regular polygon with 5 and 35/65 sides, right? So yes for A, no for B. There's your homework assignment. Give a hug, ladybug.